Hi guys, I'm Andrew from Cruisemaster and welcome to CruisemasterClass. Today we're going to be talking about common electric brake wiring faults. So trailer electric brakes require good voltage and current to work at their best. So if there are faults in the junctions or the wire leading to the brakes, that can cause big problems in optimizing your brake efficiency. One of the biggest things we find here at Cruisemaster is the quality of the connection of the electric brake to the rest of the wiring loom. A common fault is the use of these BP connectors for joining the wires. These are commonly used in domestic electrical systems, not really suited to a mobile vehicle operation. The big issue they have is you're screwing a brass terminal into the copper electrodes, and over time they can vibrate loose and you can lose good continuity of your brake wires. The other issues we find are people don't even use a connector. They do what we call a twist and electrical tape job. These particular parts are recently found on a Caravan we were doing some work on, and all they've done is twisted the wires together and electrical tape them. That means you're not going to have a good connection. What we recommend is either a nice soldered joint covered by heat shrink or a quick connect plug. These are Deutsch connector plugs that we put on for some of our customers, and they're great because they're water and dust sealed, as well as they have strain relief on the back of the wire, so you don't get any fatigue of the terminal on corrugations and things like that. Now, the other issue that we often see is voltage drop. Now, I'm going to grab some gear now and show you what that's all about. All right, so I've got a bit of a science experiment set up here, and I'll try to explain it as simply as I can. But voltage drop is a bit like pressure loss in a water pipe. The longer the wire is and the smaller it is, the more resistance there is to the current flow into the brakes. And as electric brake torque is dependent on the voltage going into them, it's a very important thing that we have to sort out. So what I'm going to show you here is the effect of using a small wire. So this is 3mm standard auto cable we've got here, which in theory is big enough for the current draw of these two brakes. So they're about 3 amps a brake. This cable is capable of 10 amps, so there should be enough there. But voltage drop is a whole different thing. So let's have a look to make sure this all works. So if we put the voltmeter here onto the battery, it should be about 13.2 volts. I'll come around the other side of the table. And I've kind of mocked something up here. We've got the two brakes connected with 4 meters of wire, which is typical of what you'd find on maybe a single axle trailer. And we're going to connect the wires down here. So now we've got 12.2 volts. So we've got a whole volt drop just between the battery there and the brakes. Now, the thing to consider about this, other than we've just got a 1 volt drop there, that is from 13 volts. On a typical car installation, you're going to have the battery at the front of the car, goes to the brake controller and goes to the toe plug. You may ultimately have a volt drop across the car as well. So if you combine that with the loss in the trailer, that's 2 volts. And when we're looking at peak brake torque and we're designing our suspensions, we're looking at 12 volts to make sure we have good capacity. And if we're losing that along the way, it's not a good thing. So right, I'm going to reset now and put some bigger cable in and show you the effect of running a 6mm twin cable instead of a 3mm. So now we're all set up again. We've got 6mm twin cable on this one. It's got higher current carrying capacity as well as more cross-sectional area of copper inside the wire, which is really important to reduce the resistance of the wire. So let's get the voltmeter out again and see what we've got this time. So there, 12.8. So on the 6mm twin cable, we've got 0.4 of a voltage drop. And on the 3mm twin cable, we had a volt of voltage drop. Now, we've only got 2 brakes on this system here. If we've got 4 brakes, we've got even more current draw from the brakes, which will mean more voltage drop. So you can see why it's so important to make sure your electric brake wires are correctly sized for the job. Now, if you've got any questions about electric brakes or wiring and stuff like that, don't hesitate in getting in contact with us here at Cruisemaster. We'll be happy to help. And make sure you keep an eye out on our social media channels for more CruisemasterClass videos.